Hi everyone, today we'll discuss about row column design analysis using our studio. The package that's required in order to run the row column design analysis is the following one: the multi-column multiplier, the e-means, and the LME4, especially to create a mixed model effect. So type this and submit to your R Studio. And I already imported my data in order to save time. Here is a column and row replication, and here is the genotype, and the remaining are the response variables. So let's see our structure. Coming to our structure, here is the column and row replication and genotype are character and integer. So we need to convert to factor using as.factor function. And for example, here we have to use the column. So type this and submit to our studio. Then again do for row, do for genotype, and lastly do for replication. Let's check back our data what's look like. Yes. So here is a column and row replication and genotype are converted from what they are into factor. Then let's create the model. I here used both the fixed as well as the random ones. Here is a fixed is genotype, and here is a row and column are used as random effect. So fixed plus random effect will create the mixed model. So you have to use here is the LMR function, and you have to indicate the response variable. Here is DT is my response variable, and genotype plus replication is the fixed, as well as here you have to use one vertical slash in order to create the random variable. His column, and again his subset with replication, and again with other type, that means row is considered as a random variable. So you have to indicate data as equals to data. That means our name, our data name. So type this and submit to our studio. Then let's see the ANOVA of our mixed model. So type this and run, and let's see. The analysis of variance only displayed the fixed effect and may not show you the random effect. So here is the genotype, and replications are the fixed effect. Then furthermore, if you want to see the intercept, so you have to use the function summary and type AV here and submit to our studio. So it will show you the correlation of the fixed effect, and again also it shows the replication, the rows and column intercept, that means the random effect, as well as the fixed effect in our studio. So if you want some detailed information, you have to use the summary and the summary function, and then write the model name that you created. Then let's go for the mean separation. I created here for this tutorial in a simple as well as in a complex way. Let's start from the complex way. As most of people require simple, some other require complex, so I just created both the simple as well as the complex way. So in order to do that, the complex one you have to use here is AV, the model that created before. Here is AV represents all these formulae, and then again you have to use the Doppler function, the pipe. So and you have to use the e-mean, that means in order to get their mean difference, so you have to use the e-means and the species, which colors here is a genotype. Then the method that we're comparing is a Newart-Roger method. Then again we can use a Take on significance difference for mean comparison. So type this syntax and submit to our studio. So let's see the multiple comparison. And over here I suggest that the Take was changed to CDAC, because Take is only appropriate for one set of pairwise comparison. So let's see the CDAC what it gives to us. Yes, on the basis of this, there is no statistically significant difference among the genotype for the DTE. The response variable is DTE. So, and again, our software gives another key pointers. A compact letter display can be misleading, and because they shows non-finding rather than finding. So R suggests us to consider using the pairs and also this method instead of the TAGE or CDAG method. So based on the basis of our recommendation or suggestion, let's use the pairs. First, you have to create the model. What we get here is AV, so then indicated by genotype. Then let's see their pairs. Yes, there is a pair comparison among the treatments. Quite unfortunate, all the p-values, as you see, all the p-values are approached to 1, so they are not statistically significantly different. So in order to say it's statistically significant, this p-value should be less than 0.05, but almost all are approaching to 1, so still our mean separation technique that we are used, the CDAC still is correct. Then furthermore, let's see the other suggestion or other recommendation functions. So you have to use this syntax all into one, and it will give you the pairwise or p-value matrix. Yes. So these are the matrix that are given again by R. So still there is no statistically significant difference among the genotype. Furthermore, let's use a graphical comparison. In order to that, you have to type plot, and MS means what we created here. What we created here is MS represents the means, and AV is our model, and here is a genotype of the treatment group. So type this and submit to your studio. So let's zoom in. Yeah, as you see here, all the blue line or the blue color shows that is a confidence interval, and the arrow is, if the arrow is overlap over the other genotype, is shows that there is no statistically significant difference. For instance, this genotype is overlap with this one, this overlap with this one, again this overlap with this one, so all are overlap to each other, so there is no statistically significant difference. To say it's difference, maybe this arrow is towards this, maybe this treatment, this arrow is towards this direction, and the other is maybe between this, around between this and this, the other is maybe somehow from this to this. So non-overlapping arrows, if non-overlapping arrows created, so there is significant difference between among that treatment. But these all arrows are overlapped, so there is no statistically significant difference. Let's see the other method, means the pairwise p-value plot. So type this function and submit to your studio, and it will display the p-values. Yes, as you see here, all the p-value is greater than 0.5, and it is around 0.8, and somehow approximate to 1 or 1. So this suggests that there is no statistically significant difference between this genotype. To say statistically significant difference, this arrow, this graph will be around 0. In the between or less than 0.05, but it is far from 0.05, even it is far from 0.5. So still our result is correct, and this graph also shows that there is no statistically significant difference among our genotypes. So if you want to get the simple method or simple way in order to get the mean comparison among the genotypes, you have to give any name that you want here, and you have to use the image function. And what we created, there is a model, then the treatment group here is the genotype, so type this and submit to our studio. And then after, you have to use here the compact letter display, which is built in the multicomp view and the multicomp package, and indicate here is the MSS and the letter is equals to letters. So type this and run. So you will get easily the mean separation. So this is all about the row column design, and if you have any question regarding to my tutorial, you can address me through my email workgenerators@gmail.com at gmail.com. Thank you for watching and have a nice time.